Hi, welcome. This is a lesson on how to use right triangle trigonometry to solve for a missing side of a right triangle. Using the trigonometric functions to solve for a missing side when giving an acute angle is as simple as 1. Label the opposite, adjacent, and hypotenuse in relation to your angle. You need to label. Labeling is going to be your friend here. Number 2, choose the correct function, sine, cosine, or tangent. Number 3, set up the equation. And 4, solve. And we'll go through some examples. This will make more sense here in just a moment. I would like to propose that when you're going over the sine, the cosine, and the tangent, that you write it. We have a mnemonic to help us remember the ratio of the sides, and it's so, ka, toa. But I would recommend that you write them out in this fashion: so, ka, toa, because that helps us remember that the sine is the opposite leg over the hypotenuse. The cosine is the adjacent leg over the hypotenuse, and the tangent is the opposite leg over the adjacent leg. All right. Write an equation using the different trig functions to solve for x. Find the measure of each side indicated round to the nearest hundredths. I'm going to pause here for just a second to get my calculator out. Okay, welcome back. All right. So in this particular triangle ABC, we're given the angle 54.7 degrees down here at angle B. And so the side opposite the right angle is always going to be the hypotenuse. I'm going to put H for hypotenuse. The side length opposite the angle that we're given is, as noted, the opposite. And then the side closest to the angle that's not the hypotenuse is the adjacent leg. And that's always going to be the case. So I look at this and I notice that I have opposite labeled as X, and I have adjacent labeled as A. No, sorry. Let me fix that. I have the hypotenuse, labeled as 7. So I am dealing with 7 and X here. I want to know what X is. So A does not come into play here, but O and H does. And so I want to ask myself here, which of the ratios deals with the opposite on the hypotenuse? And that is the sine. And so I'm going to write out my equation. The sine of the angle, whenever you have one of the trig ratios, sine, cosine, tangent, what immediately follows is the angle. And if you know the angle, then you put it like this case. If you don't know the angle, then you use a variable like x, y, b, c, or theta. So I've got the sine of 54.7 degrees is equal to, and then I've got this is equal to the opposite over the hypotenuse. And the opposite is x, and the hypotenuse is 7. So I want to know what x is. And so x is right now being divided by 7. And so the opposite of dividing is multiplying. So I'm going to multiply this side by 7, but I have to do that same thing to both sides. So I'm going to multiply this side by 7 as well. This cancels the 7s. And the only thing left to do is just put this in the calculator. Now let's go to the calculator and be careful about what we do with the calculators. So we're going to use degrees. 54.7 is in degrees. And so your calculator has different ways of measuring. So if you click on the mode button, the default setting for angle measure is radian. So I'm going to move down until it's clicking on radian. Then I'm going to move over to the right to select degree, and I'm going to do enter to, now the degree is selected. And then I can just do second function mode for quit. Second function mode quits that menu. And then I can just type in what I had there. I've got 7 times the sine of 54.7 of 54.7, and that's degrees, but I don't need to write degrees. I don't need to put degrees in there because we already changed that when we changed that in the mode. It's now going to read whatever follows the sine, the cosine, and the tangent in degrees. So close that for the angle, and then I'm going to close it for the whole thing being multiplied by 7. And it's really not necessary. If I hit enter here, it says that's 5.7, and we're supposed to find this to the nearest hundredths. And so that's 5.71. The 2 that follows means I'm going to round it off to 5.71. And we would include the units if we knew what they were, but this 7 doesn't have any units next to it, so it would just be 5.71 units. If it was feet, then it'd be feet, and so on and so forth. So that's our answer for this first one. Now I just want to show you really quick. I could also just type in 7 sine 54.7, close the parentheses for the angle measure, and then just hit enter, and it would give me that same. I don't have to put the whole thing in parentheses. Okay, so I got 5.71. This is a good example too. Okay, I know this one, opposite the right angle, is the hypotenuse. And I know this one, right next to the angle, 60 degrees, is the adjacent. And I can label this as the opposite of that angle. But since it's not really coming into play, since we're really only dealing with 5 and x here, those are going to be the only ones that I label. And that makes it less likely that I'm going to get confused here. So I've got A and H. And I say to myself, A and H, that's the C, or the cosine. And so I can set up my equation with the cosine of 60 degrees is equal to A over H. So ka toa. So it's 5 over x. And this time, my variable x is on the bottom. And so I'm going to do this as in 2 steps. I'm going to first multiply through by x to get it out of the denominator. And over here, I'm going to multiply by x. And that cancels the x on the left, but now I've got x up in a numerator. So I've got x cosine, which is x times cosine of 60 degrees, is now equal to 5. And I need to get that x alone. Because the relationship between these two is multiplication, I'm going to do the opposite, which is divide by the cosine of 60. And I have to do the same thing to both sides, so this is also then divided by the cosine of 60. Those cancel, and then I just have to put this in my calculator. So I go over to the calculator, and I take 5 divided by the cosine of 60 degrees, close the parentheses, and I hit enter, and I get 10. X then is equal to 10. And that would be our answer here. All right, let's look at example 3. Find B if C equals 4, measure of angle B equals 44. Now this time they didn't give us a triangle, so when they don't give you a triangle, you want to provide one. And you just draw out a random triangle. It doesn't matter if it doesn't fit exactly, it probably won't, that's okay. So find B, The measure of angle B, I'm going to put the measure of angle B right here, and that's 44 degrees. Opposite angle B is side length B, and C is equal to 4. Now, C is generally reserved, the capital C is generally reserved for the right angle, which means that lowercase c is generally reserved for the hypotenuse. So this C equals 4. And we want to know what little b is, and we know that this is 4. So now I'm going to label this again. This is H for hypotenuse, and the b over here, since it's not right next to the 44, but opposite, this is O for opposite. And so then I know to use O and H, which is let's see. O and H is our sine. So we go to back down here to this, we're going to use the sine ratio. So the sine of 44 degrees is equal to the opposite b over the hypotenuse 4. Once again, we've got the variable b here up in the numerator, so I'm going to multiply both sides by 4. And that cancels the 4s, and then I just need to put it in the calculator. B then is equal to, or probably approximately equal to, let's see here, 4 sine 44. So we go 4 sine 44 degrees. Now, it's not necessary to write the multiplication. Like in most cases, when you have a number and then a variable or an expression, it means multiplication if you don't have any other symbol there. So 4 sine 44 is the same as 4 times the sine of 44. And that gives you the same value there. So it's 2.77, but since the next one is an 8, that rounds it up, makes it so that it rounds to 2.78. So this is approximately equal to 2.78. All right, let's look at example 4. Another one where we have to provide the triangle. So I'm going to put my right angle right there and label that as C. We'll call this A and we'll call this B. It doesn't matter. You could switch them around. This is angle B. That means this is 22.7. 22.7 degrees is angle B. Opposite big B is little b, and that's 4. And it's asking us to find A, which is opposite angle A. So this is little a. And now we need to label the sides as being opposite, adjacent, or hypotenuse. And the hypotenuse is this one that we're not concerned with, so I'm not going to even label it, just so that we can focus on the ones that we do have. Here's my angle, 22.7, which means that this is the adjacent side. And to get easy to get confused with all of these A's here, so you might actually just want to write ADJ just in that instance. So this is the adjacent side. And then 4 is the opposite side. So I've got O and A. That means that I'm dealing with tangent. The tangent is the opposite over the adjacent. So we go back down here and we say the tangent of 22.7 degrees is equal to the opposite 4 over the adjacent A. This is another one where I've got to multiply by A to get it out from under the denominator. And I have to do that to both sides. So that gives me A tangent 22.7 degrees. When you're doing this in the calculator, remember you don't have to. This is a times the tangent of 22.7 degrees is equal to 4. So then I divide through by the tangent of 22.7 degrees and the tangent of 22.7 degrees on both sides. That cancels the tangent of 22.7 on the left, and on the right, we just go back to our calculator. We've got, I'm going to clear this. We got 4 divided by the tangent of 22.7 degrees. And that gives us 9.56, with the next one being a 2, so that would be 9.56. And once again, you would include the units if you know the units, and if you don't, you're just going to leave it like that. All right, let's look at some examples like this with the ladder here. As it leans against a building, a 9-meter ladder, it's a very long ladder, by the way, a 9-meter ladder makes an angle of 55 degrees with the ground. How far is the bottom of the ladder from the base of the building? How far up the building does the ladder reach? Okay. So we're going to find both of these. It first asks how far is the bottom of the ladder from the base of the building. And so I'm going to go in here and I say, okay, I know my 55 degrees is right here. That means this angle opposite the right angle is always the hypotenuse. And this side right next to that angle is the adjacent side. And right at this instant, I'm not concerned with y. I'll come back and do that one afterwards. But right now, I can say a and h. That's so ka toa ka a over h. The cosine of 55 degrees is equal to the adjacent side. It's a over h. The a is x over the hypotenuse, which is 9. Then I multiply both sides by 9. There we go. And that cancels the 9s. I put 9 cosine 55. 9 cosine 55. Hit enter. I get 5.16. 5.16. This is an example where we know the units because these are in meters. And so it's 5.16 meters is x. And then if I go over here, forget about the adjacent for just a second, because now 55 and y, this is the opposite leg from the angle 55. If you draw a little arrow out, it points to the opposite side. So that's the, I've got O and H, that's sol, that's the sine. So I can write then the sine of 55 degrees is equal to the opposite over the hypotenuse, and that would be y over 9. And again, I'm going to multiply by 9 and multiply by 9. That cancels the 9s, and then y then is equal to 9 times the sine of 55. 9 times the sine of 55. It wasn't really necessary to write that times, but it's okay. I hit enter, and I get 7.37. 7.37. Once again, this is meters. Now, if I wanted to kind of double check, remember that this is a right triangle. So the square of the length of the legs should, the sum of the squares of the lengths of the legs should be equal to the square of the hypotenuse, or a squared plus b squared equals c squared. So I can say here 5.16. It's not going to be exact because we rounded. 5.16 squared plus 3.37 squared is equal to 80.9. And 9 squared, as you know, 9 squared is 81. So while that's not exact, we can be confident that our answer is pretty much correct. 80.9 rounds to 81. Okay, so those are our answers. Boom, boom. Now we go to example 6. And it says a cable from the top of a 200-foot telephone tower makes a 50-degree angle with the ground. How long is the cable? This is the cable. And we're going to assume that this tower is at a right angle to the ground. They typically are. And so this then is the hypotenuse. And the 200 feet is from the angle 50 degrees that it makes with the ground. This is opposite that angle, and so we can call this the opposite leg. And we're dealing with O and H, that's so, sine. The sine of the angle, which is 50 degrees, is equal to the opposite, that's 200, over the hypotenuse, which is labeled as x. So this time we're going to have to do a couple different steps. We're going to multiply by x on both sides. Then x sine 50 is equal to 200. We're going to divide through by the sine of 50. And x then is approximately equal to, and I've got 200 divided by the sine of 50. So go in here, 200 divided by the sine of 50, and that's 261. We'll just round to the nearest foot on this, since the next one is a 0. That's 261. So this is approximately 261 feet. Because the unit is in feet, this is also in feet. So it has the same units. The side lengths all have the same units. Okay. And that's it. Practice, practice, practice. You got this.